Hi, I'm Alan Ross. I'm the managing editor of Power Systems Technology and Transformer Technology. They are publications of APC Media. I'd like to thank my guest real quick, Denis Phares from Dragonfly Energy. Denis, thanks for joining us. Bud
Great to be
Collins
here.
from AESI. And Bud, you're going to tell us what all those letters mean, right? Thanks for joining us.
Sure.
I think I know, but I'm going to let you talk about it. And then
Okay.
Kevin Schneider. Kevin, thank you for joining us. Kevin is with PNNL, and he will also share his role. But I'm really excited about this power panel because change is afoot. And yes, I came up with the title, An Evolution, Not a Revolution, because we've been waiting for a long time for the green energy evolution to take place. And I think it started a long time ago with the advent of, it actually started with hydro, probably. And then that evolution has been taking shape with wind and solar as generation. DER has changed everything at the utility scale. And I think we've all been waiting on something called storage or battery technology to catch up and make it work. And I think for you will find from this discussion that that's where we are. So, gentlemen, let me go ahead and have you introduce yourselves and your companies. Let's start with you, Denis. Dragonfly Energy and Denis Phares.
Thanks, Alan. Well, my name is Denis Phares, and I'm the founder and chief executive officer of Dragonfly Energy. And we are a lithium-ion battery technology company. Um, my background is actually pretty technical. I came from academia, and the company started over a decade ago, focused on new ways to manufacture lithium-ion cells. Uh, so although we do a lot of cell level research and cell manufacturing innovations, we're pretty unique as a tech company because we went to market with a line of battery packs that we branded Battleborn batteries after the Battleborn state of Nevada, and proceeded to bring lithium-based storage to a number of industries that really needed them. For example, the RV industry, the marine industry, and now we're really breaking into heavy-duty trucks and showing how storage can really alter the way that consumers use their power. And it's been incredibly successful for us. We were able to become profitable and really drive the R&D and the manufacturing technology that we were developing. We now have a dry electrode process that we have at the pilot line scale, and we've even showed how we can apply this dry electrode process to new chemistries like solid state electrolytes. So it's a very exciting time for Dragonfly Energy, and of course, it's a great time for storage. And I'm excited to be here. Thanks, Alan.
You know, one of the things, if you get anybody listening to this, Denis has done a TED talk. So go to TED Talks. TED, if you're not familiar with them, they're quite remarkable. But I think he spoke in 14 and a half minutes and changed the world. It's a great TED talk, something I think you will enjoy. But thank you for joining us, Denis. Our next guest is Bud Collins. I met Bud at RE Plus, and when he came up, he had this thing on his shirt and it said AESI. And I said, "So, Bud, you're with AESI," and that's because I can read a shirt. Tell us a little bit about not only that, but your background and why AESI, because you're spun out of a much larger organization.
Well, thank you, Alan, for the invite to this event. Appreciate it. Yeah, I'm I've been in the energy storage business for way too many years. Um, but one of the most significant things that we did back in 2007, we designed the world's first commercially viable lithium-ion battery system for the grid. And we designed that in 2007, deployed that in 2008 when we were A123 systems. Uh, A123 morphed into NEC Energy Solutions, and I got my team back together in 21 to create AESI. What at the time it was a division of American Battery Solutions, and AESI is American Energy Storage Innovations, and we design, manufacture, and sell grid scale energy storage systems. Um, the all of the design work done in-house. My team, throughout the years with A123 and NEC and now AESI, we've deployed over 1.5 gigawatt hours of storage worldwide. And we're bringing to market something that we think is that the market really needs. It's a game changer. It's not the standard design that everybody has been using since we did the first one. It's called TerraStore, and the first iteration of that is a 7.2 megawatt hour energy storage system with it's really an AC battery because the power conversion is included in the product itself.
Excellent. And that's one of the reasons both you, Bud, and Dennis, that you're practitioners who have not just brought something to market. You've had a good bit of experience in the market, and you both said the two words that I love to hear: utility scale. And then I could add storage and say that was three words, but utility scale, everything, because I think that's where a lot of the game changers are done. Kevin Schneider is with PNNL. I met the folks at PNNL at a conference that I was at and have talked to a number of folks there and actually did one of these with them. But Kevin, talk a little bit about your career and what you do at Pacific Northwest National Labs. And I forgot, you were Dr. Kevin Schneider.
Correct. Thank you very much, Alan. Yes, my name is Kevin Schneider, and I'm a laboratory fellow here at the Pacific Northwest National Laboratory. I also hold a joint appointment with Washington State University, and my primary area of focus is in power system planning and operations. But a big part of what I do is lead our work with the U.S. Department of Energy's Office of Electricity Program. And I do that for the Pacific Northwest National Laboratory. And PNL is one of the 17 national laboratories that are in the DOE complex. These are the national laboratories that are operated to the benefit of the nation. We kind of fill a role in between academia and industry in that we're trying to look at what's needed 20 years down the road, looking at those initial building blocks that industry will need a couple years down the road in order to make those big changes occur. And so when you look at the national laboratories, what they're really trying to do is advance scientific discovery, and they're doing it across a broad range of areas. And we're trying to tackle those big topics such as resiliency, reliability, security. Of the national laboratories, it's kind of a sibling family. There's a lot of overlap between what the laboratories do, but when you're in a research environment, there's not just one way to do things. And so some labs focus in some areas and some pick others. Within there's a number of laboratories that work in the grid area. P&L is one of the laboratories that does lead grid operations and planning. And we also have a very large energy storage program, including right now we're in the process of finishing the grid storage launch pad, which is a large facility which is designed to test batteries up to 100 kilowatt scale and do that transition from the research packet size laboratory testing to get you on the cusp of industry scale so that it can be validated there and then be ready to take it into the utility. Thank you very much.
And that's why we have these three gentlemen on our power panel. Yes, it is heavily storage because we're not trying to cover everything, but at the heart, I say in the heart of the power system is the transformer. That's why we have Transformer Technology as a magazine. I think in the heart of grid modernization has to be storage. In the heart of green energy, it is definitely storage, and there's a lot happening. As a quick opening to this, I was at the RE Plus conference. Dennis, you were there. Bud, you were there. The RE Plus conference in 2022, I was also there doing interviews, and there were 15,000 attendees and about 850 vendors. At the RE Plus conference in September, there were 40,000 attendees and there were 2,500 vendors. Now, what was the difference? And I think, Bud, you and I talked about it, is storage showed up in a very, very, very big way. For me, it felt very much like a tipping point, that suddenly we've been trying, and you remember the book, The Tipping Point. It just said an idea has to come to a point where it can't stop. Once the momentum and the weight pushes it over, you're at the tipping point. And it's not 50% or 51. It's when all of a sudden it makes a difference. I believe strongly we are at that tipping point right now. But I'd love to hear your perspective on it. Dennis, we'll start with you, and then we'll do Bud, and then we'll do Kevin, and then we're going to rotate the next question. Bud, you're going to go first, then Kevin, then Dennis will be last. So Dennis, go ahead. Tipping point.
Yeah, I agree with you, Alan. I think we are very much at a tipping point or an inflection point that I would say was largely driven by the onset of the electrification of transportation. So there's been a focus on designing batteries for propulsion for vehicles, which is great, and people love electric vehicles, and they're becoming increasingly popular. But a byproduct of that is we're transitioning a lot of that power from the internal combustion engine to the grid. So that's actually more stress on the grid. And so there's two things that happen with this transition in transportation. One, the development of better batteries, and two, the transition of a lot of this power onto the grid. So the combination of that is, well, how do we stabilize the grid? And how do we do so in a way where we're not actually producing more gas plants or coal plants? How can we incorporate more renewable energy? And of course, the answer to that is you need a buffer, and that buffer is the storage, and that storage is typically lithium batteries, because vehicle batteries have demonstrated that we can bring down the cost. We can actually have more cost-effective solutions than we've ever had in the past when it comes to lithium battery storage. So in my view, now that we've hit this tipping point, we're looking at batteries differently than we have before when it was strictly for propulsion. Now we're looking at batteries for how do we lower the levelized cost rather than increase the, or decrease the charging time or increase the range. How do you lower the levelized costs of the storage such that when you combine it with whatever renewable source you want to use so that you have a stable renewable source of electricity, that it actually is cost competitive or even cheaper. And ultimately, the big change happens when it makes financial sense. So that's where we are right now. How do we actually make this cost effective to deploy on a wide scale? And this is related to the availability of the natural resources, particularly lithium. How do we make manufacturing more cost effective? And how do we improve the chemistry such that we have long cycle life? Because the levelized cost is basically the manufacturing cost amortized over the life of the battery.
Excellent. You can't give the same answer, Bud, but I know you, so you won't give the same answer. So, Bud, tipping point.
Well, well, firstly, I very much agree with what Dennis said about the EV, revolution pushing the requirements for a change in how we generate electricity and how we distribute it. But I also think that there's some other factors at play that, when you look at the cost of storage as it's a part of the grid, back in the early late 2000s, you saw a lot of the utilities that were forward-thinking utilities, allowing storage to play a role in frequency regulation. And at that time, we were talking about $1,000 a kilowatt hour for a system. Today we're talking about $165 a kilowatt hour for a system. So the prices have come down tremendously. So as the costs have come down, now you look at other opportunities. We passed the being able to replace a gas peaker cost effectively with storage years ago. And so as we continue to develop new chemistries, make better systems that last longer, that are more reliable, deploying storage in a variety of other use cases becomes a business. And that's what it's become. And it's been really the last, I think, 3 years that we went from a very nascent industry into it's a real game now. It's a real business, and a lot of new entrants, as you said, at the show in the last, at 23, 2,500, exhibitors. Um, there's a lot of people getting into storage, whether it be manufacturers, developers, IPPs, even some of the the traditional fuel companies, the oil companies are getting into storage. They're putting money in there. So, we're excited about the industry. We're excited about the growth, but I don't think that anybody has really figured out how much storage really will be needed, because I think the proliferation of electric vehicles and also the change from fossil fuel heating your homes to pure electric and those things are going to put a tremendous strain on the distribution networks, the transmission networks. Everything's going to change in the next 10, 15, 20 years.
Excellent, thank you. When I went upstairs for a break and I was walking around, I thought I was at the oil and gas show. I saw so many of the old line oil and gas. I'm thinking, wait a minute, why are they here and why are they here? But you're exactly right. There were a lot of typical fossil fuel companies that have decided to hedge their bets. Uh, Kevin, I love the fact that you hit the nail on the head. You're that gap or the connection between a lot of academia and industry because as being part of IEEE for years and being part of the PES and the smart grid program within IEEE, I can tell you a lot of academic theory that you say that's really good. That's a 4,000 word paper. I don't understand any of it. I don't think it's applicable, but I'm supposed to figure it out and communicate it to the rest of our group. Talk about that and talk about what PNNL and you specifically are doing within that space.
So I would say that I think the key that you're really hitting on there is this idea of how do you take this from an academic, this could occur, and transition it into something that'll work not just in the laboratory, but at scale. Because this goes back to your earlier comment of grid scale. People don't always understand the actual scale that we're dealing with when you talk about a full interconnected power system. And so when you look at this inflection point, in my mind, it's really due to three things that have been hit on a bit here. The first is the technology is advancing. There's absolutely dedicated research, but we're also riding on the coattails of phones, just the lithium ion being developed there, electric vehicles, a number of other areas. And so the technology on its own is advancing. The other one is the regulatory and policy environment. It's slowly changing because we've always needed energy storage. The technology is starting to show that we can have, there's more things we could do, but until the regulatory and policy catches up and says you can do it, that really doesn't manifest itself. And then finally, the third one that brings it all together is the business case. If you have the technology, the regulatory and policy environment, then you can build the business case. Then you have the tipping point because multiple stakeholders can take this new technology and there's ways to make money with it, solve problems. And that's what really differentiates it from a DOE funded field demonstration to a mature technology that spins off companies that stand on their own and have growing quarterly earnings.
Excellent. A question that came up that I was going to ask later, but I want to ask now because of what you just said, Kevin. How much, and I'll start with you on this one, but how much is the Department of Energy slash federal government slash Bidenomics spending billions of dollars in the power grid modernization? How much is that is what's bringing about the change, the tipping point? And second question is, you can answer the first part a lot or more in detail. And the second part of the question is, what happens if that begins to go away? Is it self-sustaining from a financial business case standpoint? Bud, talk about that a little bit in terms of this tipping point idea.
Well, I think, certainly you can't have a conversation about our government's involvement without talking about the IRA Act. I mean, I think that was like putting the supercharger on the high horsepower engine. You just added a lot more horsepower to the industry because of the tax credits, both in this, in solar and in storage and the wind. That did give it a serious push. But 3 years ago, there were literally tens of gigawatts being developed in California, Texas, even over in Europe with certain projects. So I think that there was, momentum there, but the policies, pushing for the EVs, pushing to modernize, home heating and getting rid of gas for cooking and all these things that they're doing are going to push more and more and more requirements for, electricity. And everybody would like to have a green grid. They want to see, the air cleaned up and go forward with something that's sustainable. So I think that that's really a push there. So the second part, I think I lost my train of thought. What was the second question, Helen?
What happens if that stimulus begins to go away? Result of the election, one of the potential candidates is an oil and gas guy, and the other one is green energy. What if the oil and gas guy wins?
Okay. So, if you if you take away the incentives for electric vehicles, that's definitely going to slow the growth of electric vehicles. Electric vehicles have slowed quite a bit in the past, couple of months. You see a lot of announcements about cutbacks in production and from various manufacturers. The uptake isn't necessarily at the same curve that everybody thought it would be. Is it still going to grow? Absolutely. Is it going to maybe gain momentum again? I'm pretty sure it will when people get comfortable with it. But if there's a change in the IRA Act, if there's a change in tariffs, that's going to have a big impact on the energy storage. Because right now, as we sit here today, probably 95% or better of all of the cells that are made and used for energy storage are made in China. So yeah, there's a lot of Korean manufacturers, but they're typically EV centric with their products. As they shift to LFP, there may be more production coming there. There's some production from people projected to come out of Europe. There are plants that are being planned for in the United States to build cells here. But if there's a change in policy, I'm not so sure that those plants in the US will actually get built.
Okay, all right. That's a little scary because we move down the path, the government makes a change, and then suddenly we all used to be like, remember where wind was every year you had to get a reauthorization. It's kind of hard for a business to plan when you know that you've got 1 year of government funding. And when they did, stretch it out and say, look, you can plan on that, you got a lot more development happening. Kevin, the same question. How much has the stimulus helped, and what happens if it stops?
So I'd say the question of how much the stimulus helped, it's a bit of a nuanced one. I would say the answer is it absolutely has helped in varying degrees, because when you look at what that money is intended to do, it's not just meant to be a cash grab of everyone grab something, deploy it, and then move on to your next project. It's really designed to buy down risk so that the industry can get familiar with the technology, try it out, see if it works for them. And so, my thinking on this is that if you look at the industry as a whole, we see a lot of utilities, they're starting to adopt these technologies, not just because there's government funding available, but because it's meeting their needs. Now, what the government funding does is it allows more people to buy down the risk to say, will this work for our utility? Because you can't just test it with one utility and say it works across the country. We have 2,900 utilities, and what works for a large investor-owned utility, such as a Commonwealth Edison, just to pick one, is a much different scenario than a small rural cooperative in North Dakota. And so there's value in providing funds for those smaller utilities to try it out, to see how does it work for them, and there's a bit for them to learn about it. And so I think to kind of wrap that up is to say the industry is going this direction. This technology will continue to be implemented because it's solving problems in a cost-effective way. Now, what this money does is it can speed that up, increase adoption across a broader range, and just moves us faster in the direction that we're already going. And to go back to your comment of, get an administration change that says it will only be fossil fuels, that would definitely will have an impact, but you will still see numerous people deploying solar, wind, supported by batteries, once again, because it's meeting their needs. And I don't think it's an either or type of option. And so I think the future we're going to continue to use fossil fuels. Those won't go away overnight, but we do want to decrease those over time, and this will support that. And there will frankly still be applications where fossil fuels, because of their energy density and other benefits, will continue to use them long into the future. So it's not either or. This is just a matter of how do we accelerate towards where we need to get to.
Other words are like both and. It's both and, neither either.
Absolutely.
Dennis, same question. The IRA and other things that are happening with the government support, and then what happens if that pulls away?
There's so much to unpack there, so I will address a subset of it. We're so far behind China. I think that we are trying to figure out how to rapidly address that just from a homeland security perspective. The DOE is funding a lot of infrastructure type projects when it comes to mining, refining, production of cathode, production of cells, etc. There's just so much in the supply chain that we are novices at in this country. And the IRA is game changing. That $35, $45 a kilowatt hour credit has caused companies to change their entire strategies and start moving here and start planning to build here. If that goes away, it will be game changing in the other direction. So I think the bottom line is, from a homeland security standpoint, what we are collectively trying to figure out as a nation is that storage is so important. We realize we don't want to be reliant on other countries. We want to figure out how to do it domestically. We've got a long way to go, and we are, behind the 8 ball now. We're trying to figure out how to keep IRA funds domestic. The whole notion of how do you define the FIAC, the foreign entity of concern? How do you ensure that even if you've got domestic, if you have production on domestic soil, that the dollars are actually coming here and not going overseas? So you've got projects like the one in Camp Lejeune, where they had cattle cells in a Duke Energy project that had to be removed, because they were produced in China. So I kind of feel like it's a bit the Wild West. We don't know how the government is going to even enforce what they've announced, let alone what's going to happen in another administration. So it behooves us, domestic companies, to just figure out how to do things cost effectively and innovate independent of whatever the policies or whatever the government funding is. Government funding is important. Of course, we're all trying to get it. But ultimately, I think we need to be self-sustaining as businesses and not have to rely on incentives for long-term success.
Excellent. Kevin, you had a thought?
Yeah, Dennis, that's a really good point, because what I really talked about was the deployment of batteries, and that's going to continue. But I think you hit on a very important point of the question we have to ask ourselves now is, the batteries that deployed, are they going to be built overseas, or are they going to be built domestically, and what will they be built of? And I think Bill and IRA lets you start to address some of those and build that domestic capability and give us more of that at-home manufacturing base.
Excellent. This gets to the next. I want to go to the next point that we're going to talk about, and I think the rotation is, Kevin, you get to start on this one. Is advanced technologies, not only where we are now, but I've heard lithium, and as I understand it, the Chinese control much of the lithium manufacturing wherever it is, including mines in Canada and here that they own. So the advanced technologies, what are the things, and nobody's mentioned flow batteries. That was another big thing. We met with a number of people that are bringing some form of a flow battery to utility scale. But talk about the technologies that you see, and Kevin, you're great because you probably see from an academic standpoint technologies that are now being practically developed to be applied for the next stage of this. So talk about advanced technologies and the impact that other technologies are going to have on our marketplace.
So I think there's, one, as was said earlier, a lot to unpack there. Advanced technology is a pretty broad area, and so I think, starting from the very basic level, it's what are the fundamental chemistries that we should be looking at, and what are all the different variations of those chemistries. It's not as if there's just one type of lithium battery. There's thousands of variations, and they go into millions as you start to break into the different options. And I think when you talk about technology having an impact, this is where things like artificial intelligence and even quantum computing can help, because we don't have time to build and test every possible chemistry combination. And so some of those advanced simulation and modeling capabilities can help you narrow down so that you can focus into the lab of what should you be looking at, what's the highest value. And that's going to be really important as we try to move away from things such as lithium, if at all possible, and look at lower cost materials and materials that have supply chains that are less vulnerable to variability. The classic idea that if you want batteries to be cheap as dirt, they should be made from dirt and preferably local dirt. And so that's really where we need to start moving towards is, how can you get materials that aren't as subject to those supply chain disruptions? And ideally, if they can be locally sourced materials so you can manufacture them, keep costs down. And then back to what Denis was saying, how do you do that all in a cost-effective way? And that includes everything from not just how do you get the material costs down, but how do you get a business environment that has enough certainty that people can invest and build those capabilities and not have to worry about every 4 to 8 years potentially moving to the other end of the spectrum ideologically of, you can do this, no, you can't do this, now you have to do that. That level of volatility is very challenging. So I think technology that can help bring out that, try to minimize that volatility by reducing the uncertainty associated with where things are coming from is going to be really important going forward. And then the final thing I'd say is not just getting it to the point where you've got a little cell pouch testing, but how do you get it up to the utility scale? Because we've all read through the papers, and every couple of weeks there's a new chemistry that's going to save the world, but it doesn't necessarily scale up. So how do you get it to that something that becomes commercially available to the people who need to buy it and can go out and buy, I need 20 kilowatts, 100 kilowatt hours of this at a reasonable price.
Excellent. Then the same question as we talk about that. I know your company, Dragonfly Energy, has a lot. You had 85 patents up there, and you've done a lot of work with what I would consider to be the next generation, including and so, you may not be able to share this because you are a publicly traded company and you're not allowed to tell your secrets out in advance, but I know you guys are working on some amazing things. But talk about the advanced technology as you see it from an industry perspective.
Sure. Yeah. Well, I mean, I can say, and I have said already that we are working on a solid state composite solid state electrolyte that we can powder coat, and we're looking at low cost, we're looking at safety, we're looking at longevity. So those are parameters that we feel are important for a certain type of application. And if you're looking at low levelized cost distributed storage in buildings, in homes, that would be a perfect application. But there's a lot of applications. You've got centralized storage, you've got propulsion batteries, and not all of it is going to be necessarily lithium. So, the topic of sodium ion batteries or potassium or flow batteries, or all of it is on the table. It's all very application specific. Dragonfly Energy is a lithium company. That's what we focus on. We focus on manufacturing lithium batteries and production of lithium packs, and that's what we do. And we certainly have our niche applications where that's a perfect solution, and that's what we're driving for. But if there are applications where that's not the perfect solution, we're ultimately going to lose out on that market. So when it comes to developing new technologies, the question is, which applications are in need of the properties associated with that new technology? So, centralized storage, large scale storage, I think we could be talking a lot of different types of chemistries, a lot of different, maybe not even electrochemical, maybe, gravity related storage or flywheels, whatever. There's just so many different ways to crack the nut. And in my view, the problem is so enormous that it's all going to be relevant.
I want to go to what Kevin's point is. If you could come up with a battery made from dirt and make it local dirt because it's cheap as dirt, I think the world would be the path to your company. But same question. I know you've been around the changes in technology for a long time, and I know you guys are at the forefront of that. But talk about the idea that the advanced technologies, what's coming down the pike, or the application, maybe not something that you all are working on, but that you see because you see the industry.
Well, I mean, first thing I'll say is, I've been in this a long time, and the EV industry is driving cell technology. If it wasn't for the EV industry, the money wouldn't be there. Storage isn't driving the technology. We're riding the coattails of what's being done on the EV side. So, they're looking at extremely high energy density. They're looking at fast charge. They need, the longevity of the product is 1,000 cycles for an EV cell is a perfectly good cell. That's the benchmark. But when you talk about storage, we're at 12,000 cycles today. So there's a difference in the cells from EV to storage, but they're also very, very, very similar. It's the same technology applied differently within the cell itself. But I see, things starting to change, starting to shift a little bit, where solid state will be in products in the next couple of years. And I think that there'll be continued work in that area to bring that energy density from where we are in the low 200 watt hours per kilogram into the 350 watt hours per kilogram. And then who knows after that, can we get to a 10,000 cycle cell with 450 watt hours per kilogram? That's a game changer in a lot of ways. And that's coming. It's just probably not right around the corner. But at the end of the day, whether it's, no matter what technology, whether you lithium ion or, you're going to use lithium metal, you're going to use aluminum or sulfur or whatever you come up with from the cell. At the end of the day, it's the levelized cost of usable storage. If you can't hit that number, now there are a lot of technologies, flywheels, Dennis mentioned that, flywheels, great technology, lasts a long time, doesn't require a lot of maintenance. Levelized cost of usable storage doesn't cut it, not competitive. So at the end of the day, it's really the numbers that dictate what's going to be successful. Because if you can't finance it, if you can't put it in the ground, and you can't make money on it, that technology is not going to take off.
Good. Let's move, because we really, other than questions, and I've got 5 more that I want to go, but I do want to follow up on. One of the things that, as we look at it and we look at what is advanced technology, and you're looking at the industry as a whole, and you're looking at how far we've come. But when you look ahead, we've used this in the practice run-up in, and I can't remember the name of the show again, Kevin. What was the name of the TV show that we're talking? Lost in Space.
Lost in Space.
Lost in Space.
Right. And there was a robot in there, and every time this is the old one, and every time there was any danger, the robot's arms would flap and it would say, "Danger, Will Robinson, danger." And then you'd have to wait until the next episode to find out what that danger was about. Well, let me flap my arms to you all and say, danger, gentlemen, danger. What are the dangers that we face going forward? And Bud, let's start with you. Some of the things that are the unintended consequences of our actions, or just, hey, we did not see it coming. We kind of maybe thought it could happen. But talk about the future and the dangers we face in our industry, specifically related to storage.
Well, I think, one of the things, and it was mentioned before, by I think both by Kevin and Dennis, is some level of sustainable domestic production is necessary, for security, for just in general for our economy. So we've got to make sure and that the governmental uh, tempo and guidance and structure supports it, right? If we don't have that domestic production, then we're in danger, relying on, maybe it will still be China, maybe it will be another country, and maybe that other country we don't like anymore. So that's one thing that's a danger. I think that every day when I wake up, the first thing I do, and I check the news feed and I see, did somebody have another damn fire or an explosion in energy storage? To me, that is, it's unacceptable to have. And B, I don't understand why the rest of the industry hasn't, done what they should do to solve the problem. We took a completely different approach with our system, and we're looking forward to not having the issues that other people have had, because it causes a problem with just locally trying to get something permitted. The people with the pitchforks come out and say, no, you're not going to put that in my backyard, because I've heard about those. I saw that Tesla burning down the street, or I heard about a fire in New York or someplace else, and I don't want that in my street, in my town. And I think it's really up to the industry itself to self-police itself. It's not going to be UL standards or NFPA standards. It's going to be the industry itself that says, damn it, I don't want to have thermal runaway more than one cell in a system, because that's manageable. And then we push the cell industry to not have thermal runaway, period.
Yeah. Excellent. If you all remember, it was about 20 years ago where the largest lithium ion utility scale in Hawaii melted down to the ground.
That
It
was
was
that was lead acid.
that was lead acid. Oh, I thought it was
That was
lithium.
actually, in fact, I had a conversation with the woman who chose that company, that supplier, that technology over A123's LFP technology, and we were laughing about it, but it's not very funny that the people that owned it lost the money. But the fact that she said, I made the wrong decision. I absolutely made the wrong decision. And I told her, I said, it wasn't the technology. It was absolutely the application of the technology and
Yeah.
how it was operated. Lead acid batteries are perfectly fine. You just have to treat them nice.
Right. Yeah, it was a mess. I worked on behalf of an insurance company who reinsured that facility, and there was a $17 million gap between, and the company that made it went out of business, the Texas company, I think, so that
Right.
you couldn't go back to recourse for them. And that 17 million gap, of course, the utility is saying somebody needs to do something about this, and the insurance company, which was, I can't even remember now, but they stepped up with a very nice, even though they didn't have to say, yeah, because we didn't understand the risk. And then the risk became huge. It slowed a lot of things down. Dennis, you mentioned solid state battery. Let me follow up on that, because you mentioned safety. One of the things that you all have been working on is that idea, use technology to create a safer system. Talk a little bit about that.
Yeah, well, batteries can be made very safe, especially with lithium iron phosphate cathodes. You can really reduce the possibility of a thermal runaway, which of course is, each time that happens, it's awful for the industry as a whole. We look at it from a different point of view. That is, if you have a large installation in a home, then it's not just the potential for thermal runaway, but the flammability of the electrolyte itself. And so we are looking at how can we remove the potential for even the contribution of the batteries to an existing fire, because homes, you can get electrical fires, and if you've got a large battery there, then that fire is that much harder to put out. So we've been focusing our solid state efforts on that. Typically, solid state batteries, the research on solid state batteries are not focused on those metrics. You put in a solid electrolyte to block dendrites and allow for a lithium metal anode or even an anodeless battery, and all of a sudden you got really fast charging and very high energy density. So it's a little bit of a different way that we look at it in terms of our approach, and it really is the reason we did that is because of the manufacturing process. The powder coating process just lent itself perfectly to a ceramic heavy composite electrolyte. But I also want to address your question about danger ahead, and I don't look at it like that as much as the opportunity here is so, it's historically huge in terms of we could change the economics of this country if we can keep things domestic. This is the future, This is, of course, if we go back to a fossil fuel based economy globally, then we're playing with fire, literally. But the fact that we could actually take the lithium ion battery, or just storage in general, which is American innovation anyway, and just lead the world again and drive an economy, I think will put this country back on a path of innovation and profitability as a country that I think we desperately need right now.
Excellent, excellent. So Kevin, last to comment on the danger, Will Robinson from Smith Family Robinson.
Yeah, I think it goes back to what Bud said about building trust, because you're dealing with something that inherently has a lot of energy, and it's never going to be 100% safe. There's always going to be an instance or two of there's a challenge, but you need to have enough trust between the manufacturers and society that they say, okay, it happened, but we know these folks are doing their due diligence, doing the proper engineering so that we can move forward. Because what we're looking at is an industry that's going to have to move very fast to get to all those things that Dennis was talking about, building local capacity, all the new technologies. That's going to have to move fast. And then these devices are going to reside there, if they're on a utility scale, for 15, possibly 20 plus years. And so, over that time frame, there will be events that are going to have negative press. And so how do we make sure that we build that trust between the developers that say, yes, we're moving fast, but we're making sure to take the due diligence, taking safety into concern. We're looking at new chemistries. And how do you build that together? That's going to be tough. And I think it's going to be one of the things that really has to be focused on in order for it to be successful.
Good. So we've got a lot more questions than we have time to answer. I'll go through the ones I've got real quickly. For some reason, they're coming in on my phone, not on here. But is there documentation showing that BESS implementation is a lower cost solution when compared to a gas gen solution? Start with you, Bud. What does that mean?
So like I was saying earlier, when we cross that $1,000 per kilowatt hour threshold, which was years ago, that's really the threshold where you don't put in a gas peaker. The battery can provide that.
Okay.
No, we're talking not gas generation for base load. We're talking about a peaker plant. And,
Right.
You're talking about 4 hours worth of storage. So we're already there.
And unfortunately, we already have a lot of gas peaker plants and shale oil pumping. We're trying to, gas became so cheap that you saw a lot of utilities get in those peaker plants. When coal, when we started closing down coal plants, you had to now use some of them. They weren't just peaker plants anymore. Some of them you had to get your normal generation from. But good point. Anybody else comment on that? BES versus gas, Kevin?
I would add one thing that, Bud's absolutely right. There's economic cases where it pencils out right now, but I would also look at extreme events, resiliency type events. people are used to a big storm comes through, you're blacked out. Maybe you've got enough backup fuel on hand for a little bit of time. But if you have these hybrid systems that have some solar and batteries, they can operate not necessarily indefinitely, but they can go a lot longer if you start to have a major event. And I know I'm up here in Seattle, and one of the big concerns we have is a Cascadia earthquake event. We're 100 years past due. If that ever hits, you will not be able to get fuel in probably for weeks. Not that solar is necessarily the perfect resource in Seattle, but in summertime, you could possibly run 24/7 because you've got storage and some renewables. And so it's, as I said, it's not an either or, but right now there are some cases where the batteries, they win out hands down.
You just hit on one of the other questions. I want to stay on it. And so I'm going to let you talk about it again. But the question is, and the question was posed more in a negative way. How does the advancement of large scale utility scale storage impact the resiliency, reliability, and stability of the grid? So you might have just answered it, but it talked about more than just resiliency.
So I would break that into two parts. One is your local resiliency. You have a big storm that comes by, energy storage could power up house, small community. We saw this down in Florida during one of the big storms where they had a whole planned development that rode right through on batteries and solar the whole time. So that's kind of one example. But if you start talking about very large scale, gigawatt scale energy storage on the bulk system, I would say it has the technical potential to significantly improve the system. When you've got technologies like grid forming inverters, they are very fast controls. They can stabilize instabilities in the system, and they can be a real benefit. The real challenge with that, though, is that once we don't have a single utility, we've got multiple utilities operating the system. There's different power plants in different locations, so coordination becomes an issue. So where I'm going with this is that they have the technical potential. They can absolutely stabilize the system. If we don't learn how to do it in the context of the larger system, they could actually cause instabilities in the system, which is true of any large scale resource. So that's an opportunity, but also a caution.
Excellent. Thank you. Bud, Dennis, comment on that, or we'll go on to the next one because I do have.
I would say that the resiliency is really optimized when you have distributed generation and distributed storage. So you have both centralized and distributed. We've talked about the grid edge before, Alan, and the fact that you can generate and store at the edge means that locally you have more resiliency.
Okay. Go to the next one, which kind of, I love that you moved me right into the next question. The role of storage in microgrids. How important is it, and what have we done, and what are you seeing out there? Because there are more and more opportunities. I know there's a bakery in California they have 6 plants. Bakeries use a lot of heat, right? And they are off the grid. And one of the big reasons they're off the grid, I don't know how they store it, but is because of storage. They use primarily solar, some wind, but storage, and they're not using Southern Cal Edison or PG&E anymore. And I know that's bad for them, but good for us, and good for us who eat bread. So talk about the future of these microgrids and why storage will play a role in it, and how storage is already playing a role in it. Let's start with you, Bud.
So when we talk about microgrids, you can go from having a small cluster of homes or a cluster of businesses, or a microgrid could be a 10 megawatt type generating system. I think that one of the biggest things about the distributed energy storage is really the regulations. California continues to lead in setting markets and allowing for storage to participate in grid scale activities. So now you have things that are behind the meter at a business, large buildings, whatnot, and they've got storage deployed, for their systems to give them resiliency. But that's an asset sitting there that could earn some money, and now they can participate in grid activities. That's a unique opportunity in California. We want to see that go across the whole country. and all those utilities that allow that participation, because that will give us that resiliency. If you look at, the amount of money that it's going to take to strengthen the distribution network and change the distribution network to bring double the power to the homes, because they're going to have EVs and they're going to be all electric. That's not going to happen very quickly. There's a lot of capital that has to be deployed. So storage plays a big role in fitting in there and cutting down on the need to do those big upgrades, where storage can handle those peaks, those long periods of time when the grid is just overstressed or there's no power on the grid.
Same question, Dennis, and we're coming to an end here, so you're going to be our last, Kevin, on this one. But microgrids, the importance of them and how important is storage to microgrids?
Yeah, I apologize for preempting that question, because that was my point in terms of having, the distributed nature of it. But just to expand on that, I think the exciting part of it is the ability of these distributed and micro networks to contribute to a very smart grid, a software-driven grid, where we can optimize and minimize transmission and optimize efficiency. And I think that's the world where we're headed. That's the grid that we're heading towards when we start to talk about distributed generation and storage.
Excellent. So, Kevin, we're at the end here. The last word.
Absolutely. Microgrids, I love them. I think they're going to be a part of the future. It's not an either or. I think we're going to have a bulk system that provides us a lot of economic benefit. Microgrids can help us during local events as well as be collaborative partners in that. And I would say that the technology of microgrids with batteries, it's here today. I've toured Duke Energy's Mount Holly microgrid, all inverter based. It transitions seamlessly. You can't tell it. I toured a shipyard in Hawaii that 95% of the time ran off batteries and solar. That's a shipyard, a heavy industrial environment, and they were able to do it. So I'm not going to say it's turnkey off the shelf, but it's something that can be bought today, and the technology is quite advanced.
Excellent. So we've come to an end. Each one of you, when you finish something, it leads me to want to be able to talk about it, because the last question I was going to ask you, which somebody else brought up, but you just mentioned, is this whole concept of interoperability, which is using software, making it a smarter grid, and being able to level throughout the grid, which requires a lot of collaboration between a lot of organizations, from the federal government to the municipals and the co-ops and the IOUs. And I think it's going to be driven by economics. And as you said, Dennis, we've got to have a secure nation that we can supply. This to me is Henry Ford, when he created the assembly line, right? If he didn't have a national program to build gas stations across the country, no matter how many Model T or Model A Fords he built, they wouldn't have been able to get anywhere, because Stanley Steamer had everything he needed, water and wood. It was all around. You didn't have gas stations in Peoria, and they had to make sure that and it was a national, and of course, Standard Oil had a lot to do with it, the Rockefellers, and the idea that it became a national mandate to create what we now live with, which is a modern transportation system that gas could do. That's where we are. So that's my last word. Kevin Schneider from PNNL, thank you so much. Brilliant. Denis Phares from Dragonfly Energy, once again, I appreciate you, brother. You always bring great perspective and insight. And Bud Collins from AESI. I can read that across the shirt. You don't even have your shirt on, Bud. But thank you for joining us. You guys have been brilliant, and we appreciate it very much. This has been a power panel from APC Media. Thank you all for joining us.